Welcome to the Network Performance Monitoring webinar. I'm Sarah Motamen, Training and Community Engagement Manager for the ACCS project. And so this webinar is presented by Chris Myers from AARNet, which is part of the Australian Characterisation Commons scale, and a national scale project to accelerate image processing, analysis, and publication. So can you go next slide, Chris? Thank you. So we would like to acknowledge the traditional owners and their custodianship of the lands on which we meet. We pay our respects to their ancestors and their descendants who continue cultural and spiritual connections to the country. We recognize their valuable contributions to Australian and global society. So Australian Characterisation Commons at the scale, or ACCS project, is actually a data infrastructure project. It has co-investment from 10 universities. And the main goal of this project is to develop a coherent and accessible informatics landscape that promotes collaboration, increases ROI, and delivers valuable to researchers. It deploys a characterization commons for thousands of researchers who use characterization techniques, facility scientists who run instruments, and researchers using imaging collections, and will uplift the research capability offered to industry. It mainly consists of 3 specialist programs. The first one is big data electron and correlative macroscopy from instrument publication. And the second one is biomedical imaging collections and analysis. And the third one is national tools for scattering and beyond. So now I would like to introduce Chris Myers to you. Chris is a data solutions specialist at AARNet, Australian Academic and Research Network. He has 28 years of experience working in the telecommunications and higher education sector, especially in large data projects. He supports a wide array of data movement projects in training, consultation, and design in the areas of astro, high energy physics, HPC, scientific instruments, archives and film, cloud solutions, data centers, fabric, and cybersecurity. Chris is participating in work package 4 of the ACCS project and is the lead of work package 4.3. I just hand over to Chris to give his presentation about network performance monitoring, and please feel free to type any questions in Q&A function while he's giving the presentations. Thank you. Hand over to you, Chris.
Oh, well, thank you for that. Yeah, so today we'll be talking about network performance monitoring and some diagnostic tools that we use for testing how good the network is. To start off with, these are some of the terms that we'll be using, which is basically network gibberish, but they're things we need to understand, so you know what I'm talking about. So there's these elements here, which is mainly around internet protocols, networking terms like hop, path, NRANs, which is what AARNet is, packets, fragmentation, IO. So if you can try to memorize this slide right now, then we'll have a better time as we go through. Also, if you want to screen capture this, we've got a game of word bingo for you to have a play along with. As we go through the talk, you can look at these terms and mark down which ones you've got. So screen grab this now and you can play along at home. Okay, so why do we need to monitor the network for performance? You know, it helps it, you know, the real things that we need to look at is change, you know, so it informs us of change. It also allows us to set realistic expectations on the capacity, capabilities, and characterization of the network environment. So in short, tells us if it's working and tells us what to expect it to do. So just because you've got a 10 gig link to the internet doesn't mean you're going to get 10 gig because you're sharing it with everyone else at your university. some fundamental guidelines, which sort of help us to where to place these types of testing and testing systems in place. You should always try to test end-to-end, or as close as you can end-to-end. That way, from the source to the destination, if you're testing from somewhere else in your network, it may be taking a different path. Some of the university connections may connect in Sydney and Canberra and things like that. So you may be testing Sydney to Melbourne or Canberra to Melbourne, and they could be taking totally separate paths within the network. And we'll go through some of that part a bit later on. So get it closest to the endpoints because you can be taking different paths. Monitoring these systems can dramatically reduce your downtime because you can identify what part is broken or at what time that was done. So you can go back, the people fixing the infrastructure can go back through their change logs and say, yep, I did something on that day at that time and it broke everything, right? So it really helps. It's also much easier to demonstrate the issue with data and evidence rather than, it worked last time I did it, which was, I don't know, a month or two ago I tried this and it worked fine, now it doesn't. Or the internet is slow, which is a very common, vague networking issue. And my favorite is, this is why I post USB drives, which is what we don't want. We want people to utilize the network rather than having to send stuff by FedEx. So as a whole, networks do a really, really, really good job of masking the complexity behind them. So it looks like something goes from A to B on a road, but on a road network, there's all these different turnoffs. You could go left, you could go via somewhere else, you could go via Sydney to get to the suburb next door. So that complexity is well hidden and it's hard to understand where it is just from the outset. So this will give you some tools to understand, to give you capacity to understand how the data is moving and what paths it's taking through the infrastructure. This is a nice little diagram from David that he's put in for us, just to a short explanation of, a lab flow to a data store, or a cloud store, or to a HPC facility. So there's lots of steps along the way that people have to jump through. So it's not just one team, it's not just one organization. So we're crossing organizational boundaries. And if you're doing national work, you could be crossing international boundaries between different backbone carriers. And if you're going into a commercial network workspace, so to a proprietary company that's not directly connected to AARNet, then you'll be jumping through your facility, your university, the AARNet backbone, through a peering link, then into Telstra or Optus's backbone, and then into that organization. So it's really hard to coordinate that and understand that everyone's playing by the same rules, to understand that to know whether the throughput you get through that whole path is going to be the same, or if you can even do the things that you think you should be able to do. This is just a brief view of when we're looking at moving data from an instrument from a researcher to, say, a HPC system in another organization. So in this, we're talking about, lab instrument teams, the lab network, the lab systems team for the storage. Then you talk about the university's ITS division, the security teams, the campus network, the campus systems teams, and that's all within that organization. In the first organization. Then you're moving on to AARNet, which then you're talking about the network security team, the network operations team that are trying to work through moving that data. And then on the far, when you do deliver it to say that HPC site, there is the campus networking there before it gets to the e-research team, then the HP storage team, and the storage team and security teams. So there's lots of moving parts to coordinate between these organizations. And there is zero visibility of systems between all of them. So myself being in AARNet, I can't log in to the network or the systems inside the laboratory or at the university or at the other university site, and vice versa. So you have to use some of these tools we'll be showing you. You have to have access at both ends. And that can be difficult to perform when you need a login at one point and a login at the other point. And just to harp onto that complexity. So if you're looking at Australia as a network, so this is the AARNet backbone within Australia and how it's connected through all the different cities. And as you can see, most of the cities, most capital cities, state capitals, have the large dots are major router locations, and they have between 2 and 4 router locations. There's also up to 2, in some cases 3 paths going from one location to another location. And your traffic could take any of those. And if there's a fiber break or a hardware failure, or someone's pushing traffic the wrong way and we're rerouting traffic in a different direction, that path can change, and that can change your outcome and your throughput capabilities. And when you look at that as Australia as a whole, then you can move on to that at an international level, where you can see all the institutions connected down here in Australia. And then you start talking about the other NRANs, and this is just the NRANs and how they're connected in different areas. So like if you're moving data from a university in Australia to the UK, you could be traversing the AARNet network, then Singaran, and then from Singaran up to Jian, and then in from Jian into the UK. So if there's anything wrong, we need to be able to coordinate across all those 4 backbone carrier groups to work out what's going on. So this will give you some of the tools to be able to look at how to resolve those issues. And if we step up to one more level of complexity, so this is a map of the ocean sea cables of the major, just for the NRAN networks. So this is just the research and education undersea cabling infrastructure. So data can be taken any of these paths. The highlighted ones are the ones that we have direct partnerships with, but the other ones are ones that could be leveraged as well once we hop off. Like in Singapore, you can hop off into all different directions there, and Guam as well, and Los Angeles and London. There's a lot of jump offs from London as well. So having all those networks is good, but it can make things more complicated. So, so in the Q&A, just answer me, how many of you used ping before, right? Is that something you guys have done before? I'm guessing a lot of people will say yes. So all this stuff is on the Unix systems, which were transfer nodes within AARNet. So what ping gives you is a really quick view. Is the other server on the other line online? Right? Is my server on the network? Can I see the server at the other line? It can also show you whether there's loss, the TTL, because the TTL will definitely give you a big difference in the performance. And if that TTL changes, like if it goes from, like in this example here, where it's 119, say that went to 300, then you're probably getting routed via the US, 375, right? So that changes how your systems will respond. Ping's also compatible with IPv4 and IPv6. You can use both protocols on that. You can also use a -S and set the packet size, the MTU size. This allows you to work out whether your system's capable of doing normal frames or jumbo frames. So a normal LAN type frame is 1500K, and a jumbo frame is 9K. So you get a lot more data can be put into a 9K frame, a 9K packet, but when you're in a 1.5K packet, which is the normal size, it's a lot more. It can be a lot more efficient locally on your LAN to do that, rather than waiting for the payload to be all loaded up into the bigger packets. But on the long haul, the bigger packets are more efficient because you're moving more data and you have more packets in flight. So they're oh, chat is disabled. Oh, just do it in the Q&A, Jay. The cons of this, it basically only tells you right here, right now, when I run the command, what the situation is. Doesn't tell you what happened yesterday, doesn't tell you what happened a week ago, just tells you right here, right now, this is what I can see. And also, quite a few places actually block ICMP type packets at their firewalls. So sometimes you can be going, yeah, I know this thing's here, but I can't ping it. So it's a pain, but and NAT can sometimes cloud that issue a bit as well. So it's a good tool to use just for quick and dirty. Is something working? Is something there? And how far away is it? Next type of tool you can use is traceroute. And most of these tools are available in a Windows form or a Mac OS form, as well as a Unix form. All these ones will be Unix examples. So the names may change a little bit. Like I think in Windows, it's route RT, but in Unix, it's on traceroute. So in this case, traceroute displays all the possible route paths or hops, right, which is quite similar things between two systems. So from system A to system B, it'll tell me how it moves through the network. And most backbone carriers will actually specify their hops with DNS names. So in this case, you can see I'm sending something from Sydney, and it's going to one Sydney router to the next Sydney router in New South Wales. So Rosebery, Eskin Park. This one's then going to West Melbourne and then to Carlton. And then it's going to the actual destination. And the stars, the asterisks basically mean nothing's responding from that. So it's hitting, so the server's not responding to the ping, but to the trace route, but it is responding down through the path. So in this, I can tell what's happened. So it'll tell me right here, right now, what the path I'm using is. Sometimes you'll see multiples, so it means that there's multiple paths. One thing to be careful with traceroute as well is that your path may be different from their path. So you can be sending packets one way through the internet, and they could be sending them back through a different way. Like I had one case with this where I was doing a transfer with CERN, and we were going via Singapore, UK to CERN for pushing the data up, and the return data was actually going via the US through Seattle into Sydney and back down again. So you've got two totally different types of paths there, depending on which system is actually looking at that route point. So if I look at it, I go, hey, I'm doing everything via, if I look at it from my view, everything is going via the UK. If they looked at it, they go, oh, everything's going via the US. So we would have the outcome's the same, but the way we think about the view is different and the path. And also maybe blocked again. And sometimes the names can be really cryptic, you know, blah, 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 blah. And you go, oh, I kind of get what domain it's from, but I have no idea what it is. And, you know, unless you know what an ET and an XE is, you don't know whether that's like 100 gig or a 10 gig path and things like that. MTR, which is one of my favorite really simple tools. So really quick to see if something's online. It's combines both ping and trace route into the one package for you and keeps running it. And it can show you loss at each hop. So say I was sending data and there was a problem at West Melbourne, so step 4 in there, you could actually see this loss counter would be going up as the first loss counter. And that would identify for me that there's a problem in West Melbourne. So, and this one will continually work while the program's running. It won't log the information. It just runs while it's running. You can test for MTU size in this, so you can set different ping packet sizes. But really it's only going to work while it's running. So in this one, you can see it's translated all the way down. There's 0 loss, which is really good. And it's giving me sort of the average ping times. You know, and the worst ping time is 12.9. So they're pretty consistent, and they're pretty consistent all the way down, right? So that's what you're looking for. Doesn't matter how good your network going, if your CPUs are flat out or your system's out of memory, it's not going to work real well. So one of the other good tools to have on your server is TOPS built in, or HTOP, which is pretty much a colorful version of it, with some options where you can change what your view is, because TOP is mostly orientated around CPU utilization. So it gives a quick overview of the server's load, what it's running, how all the processes are running. Quite often you can see if a package you're using is singularly threaded, which means it only runs on one CPU core. You'll see, like in this case, like that server's got 64 cores in it, but only one of them will show 100% utilization and nothing else will show anything on it. And that will limit your ability to read, write, transfer. So in a lot of cases, like the old SCP clients, things like that were singly threaded, or the encryption element of them was singly threaded. So that would give you, you'd pin a core and go, hey, I've got all these cores. Why isn't my computer running? Why isn't it going faster? You know, I've hardly got any utilization, and it's because it's singularly threaded. But it's a really good quick overview just to make sure your system's running properly. IF-top. So when you're on the server, lots of servers have multiple NIC cards and multiple gateways out of them. In this is a quick, easy tool that'll show you real time what you're transmitting out of your Ethernet cards and where and when they're coming from. So like this, I know I've got some data going to this firewall 1. I've got other data from the DNS going to an Anycast for DNS name resolution, and these AWS services here. They're actually that'll be for the Globus, talking back to the main Globus server, and then some gateway information here. So you can see if packets are being sent and being received or not. So it's a quick one-stop view just to quickly make sure your network's actually doing something that you can do without having rights to your server infrastructure or doing IP link or IF config and looking to see if the packet numbers go up. So there's a quick, easy way of looking at, is the network on my server doing the right thing? And are these going out the right interfaces? So, you know, if it's going out the wrong interface, then you can have problems because, you know, you might have 10 gig interfaces in the box and 1 gig interfaces. And if you're trying to do high-speed transfers over 1 gig, that can be quite unfortunate. And IO-top, which is the same as basic IF-top, but for your disk subsystem. So it's showing how fast you're reading and writing to the file system. You can use it to diagnose whether something's hogging or you're not or there's big read and wait burst times. It'll also tell you what, you know, if you're doing a DD on somewhere else and pushing data through here, you'll be able to work out what your maximum read and write speeds are, which will definitely limit your ability, how fast you can read and write to the network once you're reading and writing to local disk. So this will let you know how it's going, and a quick, easy view of that, and if stuff's swapping and things like that. So it's definitely a good little tool to have. Downside is you need sudo or root access, so you need a fair bit of rights on this. And if you're analyzing at 2 different ends of a transfer, you need shell access to both machines, which can be a little bit inconvenient. Next part, iPerf3. It really is the core backbone tool for bandwidth testing. It will show you at that point in time what your maximum throughput is. And you can see in this, it's doing about 27.5 to 26 gigabits per second. And that's bits, not bytes. So networks are in bits. Writing to disk is in bytes. So it's like an 8 multiplier from bits to bytes. Sorry, bytes. You don't get bits to bytes. Also, one other thing to watch when you're doing this is see the retry area here, the RETR column here. Inside this will actually tell you how many retries. So that will show if you're getting high numbers in that, which will affect your transfer speed, it means you've got loss or jitter or errors or hardware errors within your network path. And those numbers get higher, the transfer speeds go down because basically TCP windowing, it ramps up and then it drops back down again, and then it ramps back up and drops back down again if you're using Reno and those sort of congestion control algorithms. You can also use this to work out your different window size or buffers, so you can custom set the buffers. You can also set how many parallel transfers you do with this. So in some systems, you can get a boost by doing parallel transfers. You can also set the port on this, so you could run 5 or 6 of these on a server if you really want to push the server and connect it to a core, so that you can have an individual core for each one of the servers running on both the server and the client. Again, this one, you need an account at both ends to use it, or someone to set you up a server or a client at one end or the other end, depending on what your server at one end. Other thing to notice with IP, sometimes it lies, which is it's not always completely accurate. So sometimes it'll give numbers that are lower or numbers that are higher than what's really happening. So there are some other tools like NUT TCP and things like that, which can, especially at the higher levels, once you start going 60, 70 gigabits per second, it can start getting a bit scrambled. So sometimes you're better off using NUT TCP for that. But this is a good tool for working out what your maximum network performance. This doesn't show you what you can do from disk, but it'll show you what your server is capable of across the network and the entire network path that you're traveling on. So it's a good way of setting an expectation of where you want to get to. So all the commands you've just shown you, they're really great commands, and I use them all the time. The problem with them is this output normal? Because you're seeing it now. If you hadn't run it before, or you're only running it when only running it when you have a problem, you go, is this normal? Has something changed? And how do I know where the issue is if I don't know what it looked like before? If I do a trace rate and go, hey, I'm going via this way, how do I know if that's different from earlier? And that's that's the main problem with all of these tools. They help good for diagnosing a problem now, or testing a system in the beginning, but you're not going to run it every day or 3 times a day or whatever to get a good baseline of how your network's performing over time, or what changes have occurred, or at what point did an issue occur, because the users only told me 3 days ago that I can't transfer data from the instrument to the HPC system anymore, or it's taking a day to do it. So you don't know when that change has occurred. So the next slide we're going to look at. So that's where, whoops, I double jumped. That's where active monitoring for the data movement networks is really important. It's something we were looking at within the ACCS project, under work package 4.3. All the other packages we looked at are free, which is really good. So we looked at perfSONAR, which has another good element. It's free. So it's always easy to get it over the line in that way. It does end-to-end throughput testing. So from a node to a node that has this software running on it, it can test backwards and forwards. And you can have multiple of these servers around different environments or different places. And they can all test into a mesh and test against each other. So that way you get an understanding of how testing is pushed around from lots of different directions. So we've got the end-to-end throughput testing. It also records loss. So any types of drop packets or loss points, also jitter. It gives you longitudinal graphing. You can create all your own tests. You can customize them. Supports IPv4 and IPv6. And it basically uses the tools from above or similar tools from above that into a single package and joins them all together and graphs it and records it for you over a longitudinal period of time. So this is what we've been looking at this for testing between endpoints, and we'd encourage other laboratory systems that want to be involved in transferring this data backwards and forwards to to look at this type of system, so that when there are issues, we have a way of looking and resolving these issues. We're going to have a look at this for real now. So I'm going to So we've got the perfSONAR element here. So I'm just going to stop this sharing right now. And I'm going to share another screen. So hopefully you can see this screen, or it will come up shortly for you. So this is the perfSONAR toolkit. So this is the main element of it. So this is one of the research ones. We have ones for our production network, and then we have ones, a couple for our research network, so that different research groups can connect into it and get a good baseline of a server that's in the center of the network, and then how that looks to other points. So in this, you get you can see what services are running on this. So you can split the services up into different systems, but we're all running them on one system, tell you whether it's running or not, give you the version and what ports it's available on. You can also then set some testing elements in here. It also tells you some basic information about the machine, whether the utilization and the memory, because you can overload it with too many tests and end up with a problem in that way. So if I click on one that so this, in this area, if you log into your version and go to config, you can go in here, you can set information about the host or alternative information. You can also customize and set your own tests. So you can work out which type of test you want to run, whether it's one-way latency, round trip latency, throughput testing, high throughput testing, V4 or V6 only, or both protocols. And you can set up those tests at one point where you can testing against another perfSONAR server, or you can do a test from both, and you can be doing it backwards and forwards. So in this, you can add hosts, add tests, and it's pretty easy and pretty fast to configure it. You can also set how often you want it to occur, the intervals in here. You don't want them too soon, because then all you're going to be doing is filling your network up with test data. You want to running it enough that you'll notice some changes, and you'll get a good little spacing over weeks and months and years of what's been happening on the network. So here's some results between two servers I've got. So PS2 and PS1 in Carlton. The top area in here, you'll see there's an overlay where you can go through and get the information that's been coming across in here. You can also see that, so it gives you a V4 throughput testing, packet loss. So you can see there's been a couple of points where there's been some packet loss in these transfers, and it's been recorded. Sometimes you want to see these in this sort of graphs happening over a period of time and regular, because sometimes it can just mean two tests have run at the same time, and there's been some interference between the two tests running at the same time. Latency, so you can see if the latency changes, and that'll give you a good indication of whether your path's changed. And also the response time will give you an indication of whether that path has changed. You can also untick boxes, so you can just look at the bits you want to look at. So if I just want to look at throughput testing, this is for the last week. I could go down to the last 12 hours, and it'll redraw that for me and show me what tests have been run and what throughput we've got on those. You can also go back to a range, say like a month, and you'll see that this is a bit more consistent. So if we go back to packet loss, and so you can see we had a period here with a bit more latency in it, and then we've fixed it up, and we've been a lot more smoother since then, right? With this transfer between these two machines. And then you can push that out even further to, say, a year. And you can see it's relatively consistent. And if there's any really big outliers, you know, it could be system reboots or things like that, you can actually highlight an area. You can jump into an area like that and set a custom time period. So let's go back to and you know, let's change this. Let's change that for, say, the last that was the 5th, so go to the 8th to the 5th. Sorry. That one, say the 12th. That. So we can bring in areas that are if we go to a custom setting, we can bring in an area that's of a lower range. So that's taken 2 days off. So I'm looking at from 2 days ago for the last week in that custom range. One other thing you can also do with the toolkit. So I can also go in here and I can look at the trace routes. So this is a trace route between this server and the Monash perfSONAR server, and you can see it step through each step. So in this, I can see like this has been this is from the last 24 hours. So you can see that this test has been running, and you can see the path's consistent. So if you're testing over a longer distance, you'll see if that path changes. Or if any of the milliseconds change, delays change in any of those elements to see if you're being tunneled in a different direction. And you can push them out to a further period of time as well. So you can set a different time period and look at a longer distance. Thing to note, it is all in UTC. So when you look at the times, they look weird, but they're in UTC time. The other interesting things with the graphs is the way you read them. So when you these ones are the best ones for this. So if I go back to let's look at this one. So don't think of them as it's filled 8 gigabits, as in, you know, it tells you, yeah, I can transfer 8. But what if you look at it the other way around, knowing that, you know, that path is on a 10 gig path, it basically, you know, around 2 gig of this data, because this service can definitely push 10 gig transfers, right? So you know on the path it's taking, 2 gig of that link is taken up. So when this test isn't running in normal operations, there's 8 gig worth of bandwidth available for me to transfer data to and from my instrument to the HPC system or vice versa. So in this, I know from my server in Carlton, I could move data at up to 8 gigabits per second on that path link to the HPC system, and it would be fine. And there's that bandwidth available. You can see some other points where it's a little more congested, but that gives you an understanding of what capability is available within that system for me to transfer data to that facility for. Okay, so let's stop sharing that. Now, did we have any questions other than the chat is disabled?
I don't see any questions, just a comment from Jay. Great detail. Thanks, Chris.
I may have a question, actually, not only for myself. I'm thinking for non-IT research people and facilities in general, research facilities or labs. If they wanted to use any of those tools, whether it's Ping, HTOP, or perfSONAR, Are they easy to use?
Yes, and they've got man pages and web pages, so they're as easy to use as any other Unix tool, where they've got all the commands list. You can, you know, if you type something like iperf space --h or --help, it'll bring you a list of all the commands with an explanation of what all the commands do and how you do that. And also, if you Google is your friend, you Google in this tool, you know, say it's iperf3, if you go example iperf3 tests, there's oodles and oodles of information up there about what commands you can put in and what outputs you'd expect and how you can change those. And also there's a very good site called Faster Data. Just get the end part of that. I just want to, so fasterdata.es.net. Inside that, so that's the US Energy Sciences Network, which is a big government network over there, but they invested a lot of time in SDMZ, which is the science gateways, and also in data transfer tools and tuning of systems. So there's a lot of examples up there on how to tune your systems to get the maximum performance out of it. And also tools up there you can download and examples on how to use those tools as well. So it's definitely somewhere I'd recommend for people to have a Captain Cook.
And would there be something like, sorry, another question. Would there be something like in perfSONAR, basically you have perfSONAR running in the background of your computer that would say your network is up or down, whether it's good time or not to transfer your data? If you wanted something like that, so basically which property or properties would you monitor?
So you would, so perfSONAR more, it's not really a network management element, right? Which is, are my systems up? You'll definitely know over time if it's not, because it won't be responding. So it more gives, that's more to give you a longitudinal view of how the network performs. Where if you're using tools like Globus and things like that, it'll actually show you whether the endpoint's up or not, and you won't be able to do it. If not, you go back to your trusty first tool that I saw, which was Ping, and that'll definitely tell you whether the server's there or not, if you can reach it.
Yeah, okay.
Yeah, so it's not really a service status element. Yeah, any other questions? Did anyone get bingo? All right.
All right, so it seems that we don't have any more questions. So thank you very much, Chris, for a great talk. And thank you very much from all attendees to join us for this webinar. We look forward to see you for the future webinars and workshops. Just wrap up this webinar today. Thank you very much. Have a great day, everyone. Bye.
Bye.